So the title of this talk is Automating Your Business with the RightScale Multi-Cloud API, Self-Service Portals, One-Click-SaaS, and more. And what we're going to go through is the RightScale platform, quick overview, how the API works, kind of about the new multi-cloud API, and then Joseph's going to walk through some examples, and then I'll walk through some actual customer use cases towards the end of what people are doing with the API. So before we get to the API, one thing I want to talk about is just the RightScale cloud platform. So one of the RightScale API is so powerful because RightScale itself is a cloud platform, and we've abstracted away a lot of the underlying cloud for you. Or we've created these blueprints of different concepts that you're used to on the cloud. So for example, what is a server? In the normal world, your server is typically located at a data center somewhere. It's a certain size of machine that you might have purchased with a certain amount of memory, a certain amount of hard disks and storage. You might have some attached disks. They're either attached through SCSI or they're attached over the network. There's some network configuration. And essentially, all this information comprises of what we typically call a server. In the RightScale cloud platform, a server is a blueprint of all those things, such that we can make it so on the cloud with what is there. Essentially, so that you can just press play, and we will do all the work for you to turn it into a server on the cloud. So on the API, it kind of looks like this. You want to create a new server, launch a server, and what we are going to do, whether or not you press play in the UI or call these calls on the API, is we go out to the cloud and we create the instance that you want with the size that you want, in the region that you want, in the availability zone that you want. And we launch it, make sure that it comes up and becomes operational. And then we continue to configure it, so we're attaching any IPs that you feel like the server needs. We're attaching volumes and making sure that those are attached in the right places, on the right mount points. So we take all these cloud constructs and we put it into what we've known before as a server. And again, in the UI, you press play. In the API, this is more of an autopilot approach, but it's doing the same thing. And there are a lot of these building blocks besides just the server concept in RightScale. So a lot of these automation blocks, we can go through. So we also have the server configuration, which we call a server template. And this is, what image am I going to use when I boot the server? Which scripts am I going to run when I start the server, such that I configure it in the way that I want it to be? It should be a database server. It should be an app server. Cross-cloud image collections. So you have an image in a particular region or an image on a particular cloud. Well, we have a construct that says all these images on all these regions or clouds are related. And so depending on where I start up that instance, I pick the right image. And I use that to start the instance. Deployments and servers. I already talked about servers, but deployments are groupings of servers that you can start up at once. So you can imagine like a rack of servers. Well, that's a deployment. You have your proxy servers, your app servers, and your database all in the same backplane. And a deployment, you can say, okay, well, this is the networking configuration that I want for the deployment, and this is the availability zone I want you to spin it up in. And a lot of that will help with the automation of the platform. Server arrays, these are, you can imagine this like a giant photocopy machine. You say, okay, I'm going to want a lot of instances that look like this. And you will go in and say, okay, this array now should be 10 instances big. We will spin up 10 instances. And you can even say, I want some of them in one availability zone, some of them in another availability zone, and we'll do that for you and keep it balanced. And we'll do all the configuration, all the management. Again, it's an automation construct. Configuration variables. So on the server templates, we allow you to say, some of the things here I want to specify at boot time. And those are what we call inputs. So all those configuration variables, like, one might be the, what proxy should I attach to as an app server? You can specify that at boot time. Monitoring alerts, escalations. This is kind of automation around what the application might be doing. So if the application is getting overloaded, you have a concept of an escalation that can take an action. In many cases, the escalation will tell the server array to give me more instances. I need more app servers. But you can do a variety of different things off of escalations. And it goes on. We have default settings for clouds. We have volume and snapshot behavioral definitions to define when you want to take snapshots on volumes and how you rotate the old snapshots, and so you don't have just a ton of snapshots lying around. Resource tagging, we can tag resources and query them so that you can say, okay, I want to get all the app servers in this deployment and do something with them. And then it goes beyond just the machines. So users and roles, for example, we can also automate the creation and permissioning of users. And finally, network rules, security groups. So these are a lot of constructs that we've created within RightScale to help you manage the cloud in a way that you typically would think of as traditional infrastructure, as well as some new things that are pretty much cloud only. And the reason why I walk through this exhaustive list is because all this is also available via the API. So the API is with all these constructs, now you can essentially, using all these automation constructs that are already there in the API, write your own code on top of it and do whatever you want with it. So Giuseppe is going to walk us through about the API and then walk through kind of how it works, what are some of the things that you can accomplish, a few examples, and then at the end we'll go through some use cases.
So let's get into some specific details that will give you a bit of an overview of the power of these building blocks before Darryl can talk about what big things you could do on top of it. Okay? So for the ones that you haven't used the API yet, this is a bit of a quick description of the flavor of what it is. It's a RESTful API, right? It's all about resources, exposes URLs that have actions, and you use the gets and the posts, and you get the normal result codes and all this good stuff that you already know. It's versions, so for every API request, basically you have to pass the version that you want to use. Right now, we're in a +1 1.0 version. Basically, what I'm going to talk about here is like the post 1.0 version that we have. So there's a 1.0 version that we have that is only for EC2 that we're going to sort of deprecate in favor of this new one. It's completely different. Okay, so this is for 1.5. We call it 1.5 because we're building more and more things to get to a 2.0 with a more of a contained set of resources. Now, the API supports two response formats, JSON and XML. We like JSON a little more, but a lot of people are actually using XML stuff, so it's good to support it. It's a bit more expensive to support, though. It has a fairly flexible authorization to the moment. I mean, as a user, logging into an account, you can use user password sort of authentication, but also you can start using OAuth. Instances is interesting enough. Instances can use a restricted set of API calls in the same way, same REST way, but they use the token that they have given to at boot time to authenticate themselves. They can only do certain things. They can not do as much as you as a user, right? So that's to avoid giving too much privilege to an instance that might have been compromised. Okay? So it's basically, whatever the instance can do is basically something very restricted to what cloud it is and what kind of things he has access to as an instance. But he needs to have access to, detaching a volume that he has or attaching a volume to itself, right? But he's not going to be able to attach a volume to another instance and things like that. And then also the API itself it's built in with something that we call filters, which is a way to query resources. So with REST, if you probably know, there's not a well-known way to query resources. You have to build it within your REST interface. So the way we build it is through filters, what we call filters, and it's kind of very consistent across different resources. So you'll see that's kind of, once you get the feel of it, it kind of makes sense across, right? Another thing that is actually quite interesting and important is something we call views. When you query data for a given resource, you may want a lot of data about that resource, or maybe a little bit of data, right? With views, you can specify how much you actually want, right? So I'll give you some examples. For example, we run into that a lot by querying clouds. When we pull a lot for resources in a cloud. Sometimes we just care about certain, the state field. Has this changed? I don't want to know, 200,000 relationships that particular resource have. So I would like to say, only give me this part of information, otherwise there's going to be a huge list. And then all of this is built around the concept of media types, if you're familiar with them, and annotated responses. So basically the results from the API call specify which what content type they have, and also what actions, what links can you follow from that resource to other related resources, or what actions you can execute on that particular resource. So I'll give you some examples on that. There's a fair amount of documentation that we have, including examples, URLs, return codes, error codes, all these things in the documentation. It's good probably to say that the documentation that this is so we generate the documentation from code rather than having somebody type these things, so that we make sure that the code is always in sync with what the documentation that is published. Okay. There's also a Ruby client that we have, Right API client, I think it's called. Yes, Right API client repo, which is kind of a wrapper for very easily making all these calls through Ruby. So if you're using Ruby, definitely check that out. I have an example at the end. All right, so that's kind of the feel of what this new API looks like, multi-cloud API. So let's take a look at how you actually use it. So let's take a look at what the media types are, in case you are not very familiar with them. A media type means that we specify for each resource types what are the different properties that you're going to get as a result. So we specify, say, let's take what do we have here? An instance, yeah. Let's take a look at an instance. We'll say, if you get instances back, you will get a certain amount of attributes. In this case, I have, name and state. A certain amount of links that are relationships to other resources related to this instance, and a certain amount of actions that you can do right now. Because of that, if you understand this format, you can have a client that reads results from the API and knows what else you could do, right? You could have some logic. So we annotate this state with things like relationships and on-the-spot actions. So that's what this is. With that in mind, then let's start giving some examples of how you use the API. First thing is that you have to do is login, right? Login is really creating a session. Creating in REST is usually doing a post on a resource. So we do a post on the sessions resource to create a session. We have to pass, there's different ways to authenticate, but in this case I pass password, email and password, right? And you have to say, I want to start a session for this particular account. I want to start a session on my production account. You do this post, you say, I want to use API 1.5, and with curl, this is example with curl, this means any cookie that I get back, save it into these files. Okay? You do that, immediately that's what it's generated from an HTTP perspective. You will get a response that says, okay, 204, no content. Really, I don't have anything to give you except 2 cookies that you should save and pass to me every time that you do more requests. So we do the post, we get the cookies, we're ready to start doing things. So the first thing that we could possibly do is maybe retrieve a resource, right? If I want to retrieve the contents of server 9999, then I do a post to servers 999. That's the typical, using a get, that's a typical REST way of doing things. And I'll get basically this. In this case, it's HTML. For example, I can specify it as a access, or I can specify it as a .xml parameter here. So I get a bunch of attributes of that server, a bunch of links, right? You see here, I have a link that it says this is the deployment. This href is the deployment where this server belongs to, right? And this is his own link. Actually, this, and it doesn't make sense because it should be server 999. That's a bad paste, right? And then in this server, I can do launch action. I can do launch action because the state is inactive, so therefore it makes sense. This server is inactive, I can launch it. If this server was operational, I would get things like terminate or whatever, other things like that. So that's retrieving a resource. The next thing is, well, maybe I don't know that server that I wanted is a 9999. So I have to have a way to to ask for given things from the API. So the first thing you could do is list all servers. If you do a get on the API servers, you'll get all servers that you have in your account. That is not necessarily super useful a lot of the times, except if you're polling. So you'll get, one server here, one server there, etc. This time, in this case, this is JSON output. But what you can see here is that, for example, this first server belongs to this particular deployment, 1111. So maybe what I could do is get me the servers that belong to this deployment. So to do that, we use the filter that I said before, and that's just as easy to say, well, I'm going to add one filter that says the deployment href has to be this. So basically, from the list of servers, only give me the ones that have this filter matching. So I'll get the same list only for servers that belong to this deployment. Okay? So it's a condition. You can think of filters as a condition of you're selecting from the servers table with these conditions. So that's a kind of an interesting way to think, a weird way to think about it, because if you want to get the servers from a deployment, you may think, I'm going to go to the deployment and then I'm going to make the deployment tell me which servers exist. But you sort of have to think about it the other way around. So that's what I mean by think bottom up, right? Basically say, well, query the index URL of the media type that you want. So what do you want as a result? A server? Well, you have to go blah, blah, servers. And then add conditions, right? That's the way to think about it. This example that we had below, all servers that belong to this deployment. So I'm going to servers. Or I can say, give me the snapshots taken from a given volume. So what am I going to go? To the snapshots. I'm going to have a filter that says this volume relationship has to be this volume. Okay? So it's kind of maybe thinking a bit from the bottom up. There's also an interesting thing to have in mind, and is that we have some resources that are exposed that are really relationships across other resources. So for example, we have the volume attachment resource. Volume attachment is an entity that relates a volume and an instance, right? If that volume is attached to an instance, there will be a volume attachment. So sometimes that you have to use that from the point of view of querying it, right? For example, if I want to attach a volume to an instance, what I want to do is create a volume attachment entity. If I have that volume attachment, is the one that relates the two, right? So I'm going to do a post, like any normal REST resource, to a volume attachment, and I'm going to pass which instance, href I want to attach it to, what volume I want to attach to, and in this case, we have to pass the device. So that's how you attach a volume to an instance. To detach it, it's a delete call on this volume attachment. So with that, you can then do a delete, and that detachment will be detached, right? So that's something to have in mind too. Now, having said this, I also have to say that there are some things that we've built some sugar on top of some of the URLs to make some things a little cleaner. For example, remember that to get the servers that belong to a deployment, we have to say, give me the servers with the conditions of this deployment. Well, in some circumstances, we actually have this. Maybe the way that you might be thinking about. You can go to the deployment, and one of the sub-resources of the deployment is servers. So this is absolutely equivalent to this. The only difference is that in the controllers here, we know already that you're scoped to this deployment. So we make that filter happen, right? It's easier, but at the same time, it's less powerful because there's only one condition that you can have there. Well, in here, you can have multiple filters, right? So, but sometimes it's nice, right? It looks nice on paper, at least. And the same thing, we can do this syntactic sugar for posts. So if you want to attach, in this case, you have to pass, to create a volume attachment, instance, the volume, and some other parameters. So you can go directly to the instances. Oh, that's a mistake. Instances / volume attachments. So the sub-resource of volume attachments of a given instance, it already scopes you to the volume attachments that belong to that instance. And then you only have to pass the volume. You don't have to pass that instance href that we had here, because it's already implicit over here. So there's some syntactic sugar in some of these calls that you also may want to know about. Enough of filters. Now, views. Well, I talked about views, right? Sometimes you query, say, the index call for security groups. Get security groups of your account in this cloud? Well, you'll get whatever list of security groups with a certain amount of information with a normal media type, right? You have names and links and stuff. Sometimes I may want to just pull for, say you're building something on top of the API that gives you a drop-down of IDs of, in this case, what is it? Security groups, right? I don't care about all these other security group rules and other relationships. So I would like to say, well, give me less information, otherwise I'm wasting bandwidth. So that's what the views are. So in this case, because there's no view explicitly done, we're going to get the default view. So this amount of information. But I can say, give me the same call with view equals tiny. And then I only get hrefs. So the names and the views of the resources are specified in the docs. I mean, it's not, we have things like default, or sometimes it's extended, or sometimes they're specific to the resource. So you can check what level of tuning you want. Now, what we've done so far is basically getting information from the API, but also, obviously, you can do actions. You can do things as easy as this. It's a post to a resource / terminate. So this server, terminate. That's how you terminate a server. That's an easy one. You don't really need to pass parameters. It's like, say, done, right? So you'll get, in this case, a no content. This doesn't work well. Okay, no content. Say, okay, yeah, terminating. You know, it's on its way down. But also, there's other ones that are a little more complex and require a long running action. So, for example, that's not the one I wanted to show. Instead of terminate, you can do run script, or run executable, I think it's called. So you can run a script on that server, and that script could take a long time to run, right? So instead of the API just saying, "Hey, got it, I'll do it," is actually saying, "Yep, I have accepted that task, and here is the location for the URL if you want to follow up on the status." Right? It's a typical, I get the task, and then I can, if I don't care, I don't care, but if I care, I can pull it. So this should be here, run executable call. All right, so let's put an example together with all these things. So this is a very simple but kind of powerful example of what you could do very easily. It's basically something we do in our own ops team all the time. It's really a rolling upgrade of the code on your app servers. You may have 50 app servers running whatever, PHP, right? And you have the code repository in Git. So what you want is to upgrade your site. So what do? You go to one, pull code, the new code, restart the web server, there you go, right? So you have to do that for all. So that's what we do here, right? This is a simplified version of what you would probably want to do, but I think it gets the message across.
Okay, so those are the basic building blocks and how you might use the API. I want to run through two examples that are actual examples that our customers are doing to give you kind of the power that this gives you. And it depends on how much investment you want to make into the API. So we have one client, which is essentially has encapsulated their entire SaaS platform into server templates and a RightScale account. So for each client that they bring on to their platform, they create a new RightScale account. They already have all the server templates for the servers that they need to stand up for that environment, and it's all ready to go. So what they do is they create the new account, share the server templates into it, and then spin it up. So a lot of this is done via the API, and I'll walk through it. So specifically, as an enterprise user, you can provision a new RightScale account via the API. You can say, I want a new enterprise child account, and here are my cloud credentials. And we will go ahead and provision that account. So they go ahead and create a new account and assign the cloud credentials. Now, they have a bunch of users that they also want to be on that account. So now they'll update all the users through the API and give them the permissions on this new account so that now their IT administrators have access to the account. There's also an input that they have in their own script, which is who's the first user of this SaaS application. And then that gets plugged in as a new user to the RightScale platform and added to this account as someone who can operate on this account and create additional users for this account. Again, all this is done via the API so far. Now, they have a master account somewhere else where they have all the server templates. And what they do is they are in the new account, and they will import those server configurations into the new account. So we've now, as of about March, we added the ability to share templates via the API as well as to import them into other accounts. So you can now move templates around programmatically if you have multiple accounts. Then they create a new deployment. They create all the servers within the deployment. Again, they're using the server templates, so they have their Goldmaster server templates. They start all the servers up with the appropriate parameters. And at the end, they query and say, okay, I want to get back to that particular URL, the front end, and they give that back to the client. So this was a decent amount of investment for them, but now they have some 140 accounts that they're running as separate SaaS platforms, essentially, within RightScale, and it's fully automated. It's so automated, in fact, that you actually go to their website and you'll plug in, I want to spin up a new environment, here's my email address, and it just happens, and you get an email, and it says, here's your new environment. So that's a really cool use case that they've come up with, which is just a one-click SaaS model. And they're not the only ones doing this. We have another SaaS company that's starting to, they do it through the UI now, but they're porting it all to the API. Another use case, which if any of you were in the session this morning, you saw Pearson doing with their sort of, overview, one-click vending machine. And this is probably the more common use case. So I can name 10 customers that are doing this right now on our API. We initially built kind of a self-service portal within the RightScale UI, but then found out that people didn't want it because they wanted to customize it, tie it into their own ticketing systems, things like that. So the typical vending machine goes like, you display a list of approved configurations to users, and that's just your web page. The user selects a single configuration. You can then prompt for whatever inputs you need, like a username and password for the application. You create a new server based off of that configuration that you're offering. You launch it. You might tag the server, maybe with a department name or the user for later reporting on it. You get the public URL and IP. Once it's operational, you return that to the user. The user logs into the application, with the provided username and password that you gave back. And then later, and we're adding this to the API actually next month, but you can do it through the UI now. You'll be able to pull a report on a periodic basis to show the spend for whatever tag you added right here. So that's another common use case. For example, we have a lot of gaming companies that do this. They'll put like a big PHP front end, and there's a certain stack that they use for all their games, and you say, I want 100 servers with this stack, and here's the code URL that you go and pull the code from. And here's the data URL, or here's the URL to the data dump to seed it, and play. And it goes against our API, creates a new deployment, spins up 100 servers, runs all the code pulls, and sets up the databases, gets it all going. And that's very specific to their environment, but they've automated it all so that they can scale very quickly. So those are two use cases that show kind of the power of the API and save people from a lot of clicking. We're adding a lot more reporting, and that takes me to the next slide as to what's coming. I'm going to start adding more of the cost reporting to the API. So here's just a little preview of some of the things that are coming up. With the new multi-cloud API, you can pretty much do a create on almost any resource. Multi-cloud images, server templates. The one final one remaining that we want to get in there is what we call executables, which can be either write scripts or chef recipes. So right now you can read them, you can see what's on a template and on a server, but you can't change it. You can't change the actual script. So we'll give the full create, read, update, delete on scripts. One of the common use cases that we hear, people want to maintain scripts and stuff in an external repository and essentially just push it into RightScale, into the automation framework, such that you don't have to maybe keep your write scripts in RightScale. You just build everything on the fly and then go from there. So we hope to get that out in Q3. Cost reporting is going to be coming up in the next couple of releases. What this will allow you to do is create reports. The reports can essentially have fields that you want to have in a CSV, so you can specify the fields in the CSV. And then you'll also be able to specify filters, so you can say, I only want to get the usage data for this particular user. And then once you create a report, you can also execute the report or schedule the report. So a lot of that will be coming out as well. We do have a private beta going on right now around federated identity, specifically SAML single sign-on. And one thing that we'll also be adding to the whole user provisioning section of the API is the ability to send in a SAML identifier. So now you can have a fully automated user provisioning system that lives outside of RightScale, so you can sync with your Active Directory, things like that. And then eventually we will retire the 1.0 API, which is the EC2 only API. And currently we are on what's called 1.5. This is the multi-cloud API. And when we roll Amazon into it, it will become 2.0. A lot of what is going into this API is being set now, so if you do have specific requests, we would love to hear your feedback. But that was mostly about it. A lot of our documentation, again, is on support.rightscale.com, and you can go to the reference documentation there, and it's hard to read the blue there, but you can easily find it when you're on the site. And then we have both extensive documentation for the new multi-cloud API, as well as the current EC2 API. And yes, questions and feedback, we can continue that. And then, yeah, any specific requests, please come up to me and I'll make sure to write them down.